So now we're ready for Module B, another review section. We're going to look at graphs and functions, primarily focusing on linear functions, linear equations, y equals mx plus b in general. But we also will look at just graphs and functions in general here. And so what we are going to look at first is how to find x and y intercepts. So for x-intercepts, we look along the x-axis wherever our graph would intercept that x-axis, we get those x-intercepts. So this first one we've got here, we can list the x-intercept, abbreviate a little bit. We can list it as the point 1, x value of 1 with a y value of 0. And you'll notice all x-intercepts will have a y value of 0 because it's right here on the axis, right? And then the next one would be 3, 0. So those are listing them as points. Sometimes Alex will just want the value of the intercept itself. So as you put it into the homework, it may want just 1, 3. So those are your x-intercepts. I like really x-intercepts are points. Listing them as points will remind you that the y value is always 0. Likewise, to get the y-intercepts, well, intercept, because of being a function, since y is a vertical line, there will only be at most one y-intercept. Suppose it's possible that there are no y-intercepts. Well, we'll see those examples. But we'll use a little different color here. So we look for the place along the y-axis where the graph crosses that place. And so what we can see is that it's the y-intercept is, the y value is -3, the x value is 0 because we haven't gone left or right. And so we can write that as 0, comma, -3. Okay, and again, sometimes if they just want the value of the y-intercept, we put the number -3. But again, if we just have numbers, it's hard to distinguish which are x-intercepts, which are y-intercepts, except by where they're listed as answers. But when we list the coordinate of the point, we're very clear that 0, -3 is a y-intercept because it's got an x value of 0. Okay, so that's how we go about finding intercepts. And we're going to look at now, getting into more of a look at linear equations, straight line equations, and how that graph, we might look at the meaning of the y-intercept as well. And then along with that, that's sort of the b part, right? We've got this equation, y equals mx plus b. I don't know why my writing utensil is being so weird today, but it is, which is also, sometimes we'll see this written as b plus mx. Those are really the same thing, right? Because addition, we could do it in either order. Here we go. Okay, so the y-intercept is going to be our b. So let's look at the question first. So Milan is draining an aquarium. The graph shows the amount of water in the aquarium versus time. So from the graph, we can pick up what the x value is. So x is time in minutes. So the units are going to be minutes. And then the y value is going to be the amount of water. So y will be in liters. And when we go to find the y-intercept again, we go where x is 0, that's the y-axis, and we look where does the graph cross that y-axis, or touch it. In this case, we could imagine it going through it, but at time 0, we can see there was 108. So the y-intercept, now this is where it's valuable. We could list it simply as 108 liters, and this is sort of how we can differentiate which variable we're talking about is with the units. and realizing every number that we use should have some sort of units on it, some sort of value. So it's 188 liters. We can also list it as the 0.0108. And that again emphasizes that this is time zero, there's 108 liters. So that's what the aquarium has in it, and then it goes from there. I guess I should have put the question, what is the amount of water in the aquarium at 0 minutes? That's the y-intercept. So doing a little Jeopardy today, giving the answer before the question. Okay. So now, as time increases, let's go for the B part, we'll change color here. Time is increasing. Is the amount of water in the aquarium increasing or decreasing? So we're reading from left to right, and we can see that the amount is going down. So that's going to be a big feature that we're going to look at. So we can just say it's going to be decreasing. You remember from your exploration of linear equations, this would mean our slope is going to be negative, right? So, but that's one of the things we look at. And then finally, at what rate is the amount of water increasing or decreasing? Well, it's decreasing. What we need to do to find the rate is we need to find a second point. And so let's go with that black. And so what we look along is along this line, there's a couple nice values that will give us points that we don't have to interpolate halfway between. So there's actually several of them. We could use any of these. I guess we could use this and assume it's 4.5, but it might not be. So wherever it goes through a crosshair, those are going to be good points. And if you're like me, you like to make the math a little easier, so we'll make the numbers maybe as close together as possible. So I'm going to choose this one here, which is the 0.184. Okay, and of course, the other point that I could use any of the others, but how about the 0.0108? So using these 2 points, what I do is I find the rate, average rate, which as you can see with the straight line, the average rate will always be the same all along that line, is I use a slope formula. The slope is going to be y2 minus y1 over x2 minus x1. Now, if you're like me, I don't really like plugging into formulas as much if I can find another way. And what I found is there's a kind of this cool way, is you can put 1 point above the other vertically. I'm going to head put the second point here, so 184. And then below it, I'm going to write the other one, y1. And I remember that the first one is my x values, the second one is my y values. I subtract the points, one from the other, point by point. So 1 minus 0 is still 1. 84 minus 108 is going to be negative because I'm subtracting a larger number from a smaller number. And let's see, if I flip it in my mind, 84 from 108 is going to be 16, gets me to 100, and then another 8, so that's going to be 24, negative 24. And then what we do is the slope has the y in top, so I take the x and I tuck it underneath the y, and that gives me my average rate of change is negative 24. So that's my rate. Now the negative means we are decreasing. So if in an answer, so it was decreasing, and oftentimes in the answer they will ask you whether it's increasing or decreasing. If you say it's decreasing, then you list the rate as positive 24, because it's the negative means decreasing, which you've already given that piece of information. And so within the Alex system, you'll see if you tell them it's decreasing, then the rate, we would say something like this, decreasing at, if I can squeeze it in here, 24 liters per minute. A rate also always has units on it, liters per minute. Okay, so that's an example of something you'll be working on. Oops. Okay, there we go. I've never had the writing follow into the next slide before. So now we're going to use it to solve a word problem. And again, we're going to look at how to find the equation of this line that we're being given. Again, the graph helps us in telling us what the x values are, the units. So x is going to be in minutes. Tells us the units on the y, so that's going to be in dollars. And it helps us set this problem up. Okay, so first of all, as we read through this, we got credit remaining on a phone card in dollars is a linear function, total calling time made with the card. So what we're looking, the remaining credit after 36 minutes, remember minutes are going to be x values, so that's an x, is 25.32, that's a y value. And the remaining credit after 75 minutes, which is also, that's an x value, is 20.25. That's a y value. So what they've given us is 2 points. And then we want to find the remaining credit after 88 minutes, which again is an x value. So one way to approach this is to take these 2 points, 36, 25.32, and subtract them. Okay, get the rate. We'll find the equation of the line, and then at the end we'll plug in the x value requested and be able to calculate the y value. So our 2 points, 36, 75, and this is 20, 25. Okay. So first step is, again, we're trying to get it in, it's a linear equation, we can see straight lines, so we want y equals mx plus b. So we want to find the rate of change, which we'll do as we did last time. Again, you can plug it into the formula, or you just remember you've got x is your first coordinate, y is your second coordinate. You can subtract them just by lining them up. So 36 minus 75 is going to be a negative value. And that is going to be, swap them. I always put the 75 on top in my mind. Take 36 away. That's going to be 39. It's good to double check it. That's good. I'm probably going to need to use a calculator on this anyway. And then 25.32 minus 20.25 is going to be 25.32 is 20.25 gives me 507. And so we divide that by 39, negative 39. We can see it's decreasing, so that's good. And that gives us a slope of 13 cents a minute. So they're charging us 13 cents a minute for using this phone card. Okay, so what we've got so far is we've got that y equals negative 0.13 x plus b. Now to find the y-intercept, the b, which is going to be the starting value, that's kind of nice to know what this card is. Maybe it's a $30 card, maybe it's a $40 card. We could probably figure that out. But what we can do is take one of the points, and here's point 1, here's point 2, and we plug it in. So I'm going to take point 1, and so for the y value, I put in 25.32. That's equal to, and don't forget that negative, times the x value, which is 36, plus b. So I'll do the arithmetic. So 0.13 times 36 gives us 468. Okay. And so we add the 468 over to the 2532, and certainly we do come up with the value that b equals $30. So that was the initial cost of the card. We know that the equation of this line, let's go ahead and do it on the graph, is going to be y equals negative 0.13 x plus the y-intercept, which is 30. So we buy the card for $30. It's going to cost us 13 cents for each minute we use. And so now we can figure out how much would be remaining after we used up 88 minutes by plugging x equals 88 in for the x value. So then we get y equals negative 0. Times 88 plus 30. So we go ahead and take 88 times 0.13, negative 0.13, we get negative 1144, and we add that to 30, we come up with that after 88 minutes, the y value is going to be $18.56. Okay, so we've answered that question. Take 2 points, find the slope, use it to find the full equation by finding the y-intercept, and then plug in the value. So you also have questions about evaluating functions, so we'll do this some more throughout the course actually. So let's go ahead and take a look at this. How would we find f of negative 3? So what that's saying is x is negative 3. So we take the model, the function itself, and we could say that f of negative 3 is going to be equal to, and what I do is the first time through is I change the x value to a big open parentheses, 5x plus 4. And then what we do, change colors is we plug in the input, so differentiating the function from the input, and then calculate it. 5 times negative 3 is negative 15 plus 4. And so then we end up with f of minus 3. Negative 15 plus 4 is going to leave us with negative 11. And notice how our final answer, we've got the input value of negative 3 and the output value of negative 11 right there in the answer. So let's change colors here. When we look at g of negative 4, so negative 4 is what our x value is. So we evaluate that as g of negative 4 is going to be equal to negative 2 x minus 3. Again, our input is negative 4, so that goes in for where the x was, and we follow order of operations. So in this case, we're going to take negative 4 and cube it, so that's negative 4 times negative 4 times negative 4. It's going to be a negative number, and 4 times 4 is 16, times 4 more gives us 64. So negative 64. And we're going to multiply that by negative 2, and then we're going to subtract 3. Just following along in the order. So a negative times a negative becomes positive, and 64 times 2 is going to be 128. Minus 3. And we could keep writing this g of 4. I'd like to just wait till the very end. Just bring it on down. And our final answer is going to be 125. Okay. So those are the examples to take a look at that will get you through Module B. So it's the end of our direct instruction part. Now you'll want to go in and complete the activities for Module B. Keep moving on. Again, if you run into any difficulties, we've got our online tutoring, instructor office hours, and again, working with peers through the discussion forum. You post your questions there and include a little bit of work if you can, so we know what tact you're taking, and then myself and the other students can see that and answer questions. All right, so good luck and keep the forward motion.